Hi all, continue for the next lesson of Basic Electrical Engineering course. So, in the first lecture we have discussed about the alternating current fundamentals, that is the generation of alternating EMF and derivation of instantaneous EMF equation, that is E is equal to Em sin omega t, and we have already drawn the waveform for an EMF, alternating EMF, and we have discussed about certain terms relevant to the alternating currents, that is we have discussed about what is cycle, what is time period, what is frequency, what is instantaneous value, what is average value, what is amplitude, etc. So, in today's lecture, we will be discussing about root mean square value, that is RMS value. What do you mean by, or how can you define RMS value? RMS value actually gives an indication about the heating effect, that is I square R in terms of I square. Okay, RMS value can be defined as it is that value of DC current which when flows through a given resistance for a given time produces the same amount of heat when alternating current pass through the same resistance for the same time. So, that is the definition of RMS value, root mean square value. I will repeat, RMS value is defined as that value of DC current which when flows through a given resistance for a given time produces the same amount of heat when alternating current passes through the same resistance for the same time. Okay, that is RMS value. It is otherwise known as a virtual value. RMS value is otherwise known as virtual value. And for the determination of RMS value, mainly there are two methods available. One is analytical method and the other one is analytical method, and the next one is mid-ordinate method. Mid-ordinate method. One is analytical method, the other one is mid-ordinate method. And for sinusoidal waveforms which we drawn in the first lecture, that is you have alternative positive and negative cycles, for that kind of waveforms it is easier to use analytical method. But for non-sinusoidal waveforms, it will be good to use mid-ordinate method. Okay, first we can see what is analytical method. So, analytical method is otherwise known as integral method. Its another name is integral method. Analytical method is otherwise known as integral method. So, we can see what is integral method. For that, I am taking an instantaneous value of a current, that is I is equal to Im sin omega t, which we have already derived, right? I is equal to Im sin omega t. Now, I have to get the root of mean of squares value, right? That is RMS value, root of mean of squares. So, what I am going to do is, I am going to take the square of this current wave. So, in the next line, I can write the equation of squared current wave, can be written as I square is equal to Im square sin square, or theta instead of theta, maybe you can write omega t, you can write theta, Im square sin square theta. So, we are going to find out the RMS value of an alternating current. Okay. So, the equation for current, alternating current, instantaneous value of alternating current, I is nothing but Im sin theta. So, I want to find out what is root mean square value. For that, I am taking the squared waveform, that is the equation of the squared current wave I have written like I square is equal to Im square sin square theta. Now, we are going to plot this waveform. So, how can we plot? First, you plot the waveform for I is equal to Im sin theta. Suppose this is my small letter I, that is nothing but Im sin theta. This is Im sin theta. So, you now have to draw the squared waveform I square. So, squaring, right, magnitude I am putting like this, negative square is again positive. So, this is my I square waveform. That is I square is equal to Im square sin square theta. Okay. So, on the y axis what you have is instantaneous value of current. So, this is I is equal to Im sin theta, and this blue color is your squared wave, that is I square, that is Im square sin square theta. So, we need to find out the RMS value of this particular waveform. So, first what I am writing is the mean of squares of the instantaneous values of current I am taking. The mean of squares of instantaneous values of current, over the half cycle is equal to, how can we find out the mean of squares of instantaneous values of current over the first half cycle? So, this can be obtained by taking the area over the half cycle and divide it by base. That will give you what is RMS value for this particular waveform. So, I am writing this as area of first half cycle, divided by its base. Area of first half cycle divided by its base. Specifically, if you want, you can write area of first half cycle of the squared wave. Otherwise, you will get confused, because whether you are taking I, you could be mistaken. So, you have to be careful that area of first half cycle of squared wave divided by its base. So, now it is clear, you will not be confused. Squared divided by its base, because we are going to find out the mean of squares of instantaneous value. So, obviously, you have to take the squared waveform. So, in the next line you write, how can you get the area of first half cycle of the squared wave? For that, this method I already mentioned, this is otherwise known as integral method. So, I am going to take the integral over, here I am marking it as suppose 0, pi, and this is my 2 pi point. So, we are taking up to this half cycle, right. So, 0 to pi we are considering. So, what I am going to do is to find out the area of first half cycle of the squared wave. I am integrating from 0 to pi. What is the equation? Squared waveform divided by, what is the base up to this half cycle? That is nothing but pi. You are integrating from 0 to pi, squared waveform divided by its base is nothing but you are considering half cycle. So, 0 to pi, so pi is the base. So, you can substitute for I square as 0 to pi. I square is nothing but Im square sin square theta divided by base is pi, right. So, I know that Im square, that is maximum value of alternating current, right. Im is maximum value of alternating current. So, obviously, it will be a constant. So, I am taking that outside. Im square divided by pi remains outside. Integral 0 to pi. What remaining thing I have is sin square theta, which I am writing like 1 minus cos 2 theta by 2. I am writing like this, 1 minus cos 2 theta by 2, that into d theta. Okay. Sorry, here one d theta is there. That is, we are substituting I square as Im square sin square theta, d theta divided by pi. So, Im square is being constant, I have taken it outside. Im square by pi. Sin square theta I have written like 1 minus cos 2 theta by 2. So, I have to integrate that from 0 to pi. Now, in the next step, after the integration, we can write it as, how we can write? Im square by pi, that remains the 0 to pi theta 1 minus cos 2 theta by 2, right, theta minus sin 2 theta by 2 within the limits 0 to pi. So, on substituting upper and lower limits, I can get Im square divided by 2 pi, then theta within the limits 0 to pi. So, finally, what I will be getting is pi will get cancelled. So, Im square by pi. I got Im square by pi as the value for this thing. What is this? That is the mean of squares of instantaneous values of currents over the half cycle. Now, what we want to find out is nothing but RMS value. So, this mean of squares I have found out. So, next step what I have to do is I have to take the root to find out the RMS value. So, in the next line I can write it as, therefore, so this is a derivation for a sinusoidal current. For sinusoidal current, this analytical method is okay. So, in the next line, therefore, root mean square value is equal to, what I have to do? I have to take the root of this thing. Sorry, there is a mistake when I have written pi gets cancelled. It was Im square by 2. I have mentioned like Im square by 2, but mistakenly I have written like Im square by pi, sorry. So, it is Im square by 2. So, I have to take the root. So, I am putting this in root Im square by 2. So, I can write Im divided by root 2. So, what is the value of this thing? You check what is 1 by root 2, it is 0.707. So, I can write 0.707 Im is the RMS value of a sinusoidal quantity. Any sinusoidal quantity will have an RMS value of 0.707 Im. If this is a voltage waveform, the same thing happens. We will write like E is equal to Em sin theta, E square is equal to Em square sin square theta, like that. So, finally, the value you will be getting like 0.707 Em instead of 0.707 Im. So, RMS value of current for that particular network, we can write it as IRMS. You can put this in a box, okay. Always you should remember this. IRMS is equal to Im divided by root 2, which is equal to 0.707 Im, okay. This is a very important relation. You should remember this. This is the RMS value equation, okay. Put this in a box. And next we will look into what do you mean by mid-ordinate method. This was analytical method, which is otherwise known as integral method, because we are integrating this from 0 to pi over the base of pi, right. So, this method is otherwise known as integral method, remember like that. So, first what you have to do is that if you want to find out the RMS value, that is root mean square value, first you have to square the waveform. So, if you have a current waveform of I, first what you are do is you have to square it. So, you will be getting I square. Now, you find out what is the mean of squares. So, in order to find out the mean of squares, what you want to do is you have to take the area over the first half cycle and divide it by base. That will give you mean of squares of this particular value. So, after finding out that you will be getting it as Im square by 2, that is the mean of squares of instantaneous values of current over the first half cycle, that is Im square by 2. So, next what you have to do is you have to take the RMS value. For that you are putting root over this. So, root of Im square by 2 is nothing but Im by root 2, that is 0.707 Im. So, this is very important relation. This is for a sinusoidal quantity. Sinusoidal quantity. Because this kind of waveform we are calling it as a sine wave. This is your sine wave. So, sinusoidal quantity, this RMS value is 0.707 Im. Peak value into 0.707 will give you what is RMS value. Okay. So, we are moving on to the next method, that is mid-ordinate method. So, I am wiping all this. Hope you have written this in your notebook. So, next you write, in order to find out the average and RMS value, we will write for average value. For finding out average value, next step, for finding out average value. First we will be discussing about mid-ordinate method. So, in the last lecture or in the first lecture we have discussed about the definition of average value. What is average value? Average value is nothing but the arithmetic mean of ordinates over a half cycle at regular interval of time, right? That was average value. So, if you do not remember that, just remind it that average value is nothing but arithmetic mean of the ordinates at regular intervals of time over a half cycle. We are considering only half cycle because for if you are taking for both positive and negative full cycle, it will become 0, average value becomes 0. So, we have to consider only the half cycle. So, now we can see how we can find out the average value, okay, using mid-ordinate method. So, consider this diagram where we are considering only a half cycle waveform. Suppose I am having a current waveform, I am drawing like this is my positive, I am concentrating only about the half cycle, okay, and I am dividing this into number of samples like this, okay, number of equal sections I am making and considering the mid points, I am considering the mid points, okay. So, draw a waveform like this. Here we have time, or we can write it like theta only. Suppose theta. We are dividing it into sections like I1, I2, I1, I2, etc. up to In. We are dividing into number of sections. So, you draw this diagram and make the assumption that let the waveform is split into equal intervals of time into number of sessions, and by taking the midpoint of these I can write the average value by considering the mid values average value, I average I can write like we have number of sessions up to In. I have to take the arithmetic mean of the ordinates over a half cycle. So, I1, I2, etc. up to In divided by n. This base will give you what is I average. This is known as mid-ordinate method. So, how to write this in analytical method? How to calculate this average value using analytical method. So, here also I want to find out the total area of the half cycle and divide it by base. But importantly, you have to note that here we are not squaring the waveform because we are not finding out root mean square value. Here what we are finding out is average value, right. So, you need to square it. So, suppose you have a waveform of small I which is equal to Im sin theta. Suppose this is your waveform, then you have to find out the total area of the half cycle and divide it by the corresponding half cycle base. That is, here it is considering as pi. Suppose this is 0 and I am marking this as pi. So, your base will be pi. So, analytical method, first you write average value is equal to the area over the half cycle divided by its base. So, first you find out what is the area. Okay. First you write, let us assume I is equal to Im sin theta. This is the current equation what we are considering here. So, in the next line I want to find out area over the half cycle. So, how to find out the area over the half cycle? you have to integrate it from, suppose this is 0 to pi, right. So, I am giving like 0 to 180 I dt. If I am taking it as 180, I am putting I into dt, otherwise 0 to pi I d theta. Okay. So, I can substitute for I as integral 0 to 180, I is nothing but I m sine theta d theta. So, integrating, I m is constant, you can take it outside, sine theta, what is integration? It is minus cos theta, apply the limits from 0 to 180. So, what is the final answer you will be obtaining? The area over the half cycle, so I am wiping this off because this was for the mid-ordinate method. Now, we are dealing about analytical method. Okay. How to find out average value using analytical method. So, area you have obtained. So, what is the final answer for the area? It is 2 Im. So, I am writing again, area over the half cycle, is equal to, by doing this, applying this limit, I can obtain it as 2 times Im. This is my area. Now, in the next line, you write base over the half cycle. For average value, you are taking only the half cycle. So, base over the half cycle is nothing but pi. So, in the next line, you write what is I average. So, average value I average is equal to nothing but area over half cycle divided by your base. So, substitute for that. What is area over half cycle? Area over half cycle we have written like 2 Im, that divided by pi will give you what is average value, that is 2 by pi into Im. The value of 2 by pi is, you check with it, 0.637. Okay, value of 2 by pi 0.637 Im. So, finally, I got the answer like this for the average value of alternating quantity. This is the average value of alternating quantity when I am doing using analytical method or integral method. Okay, area over half cycle you have to find out, that divided by base will give you what is average value. So, here it is obtaining like 0.637 Im. So, initially we have put it in a box for an RMS value like that. You can put this also in a box, that is average value of current I average is equal to 2 by pi Im, which is equal to 0.637 Im. So, this is another important relation which you should remember. This is for a sinusoidal quantity. Okay. So, these values you should remember, that is RMS value IRMS was 0.707 Im like that. Average value I average is we obtained as 0.637 Im. Now, two factors also we have to discuss. What is form factor and what is peak factor? So, next we will be writing. So, these two relations I am putting here because it will be needed for later substitution. So, I am writing here, that is IRMS is equal to 0.707 Im and I average is equal to 0.673 Im, isn't it? Sorry, 0.637 Im. So, first factor which you should remember is what is form factor. This is an important factor you should remember for any alternating quantity. What is form factor? Form factor is nothing but it is a ratio of RMS value to average value. So, you write form factor is defined as the ratio of RMS value to average value. So, I am writing like this, form factor is equal to RMS value divided by average value. So, you can substitute like RMS value is nothing but 0.707 IM divided by average value is 0.637 IM. So, what is the value you are obtaining? For form factor it is, I think it is 1.11. So, this is the equation for RMS value, that is 1.11. This is for a sinusoidal wave. Okay, this value is applicable only for sinusoidal wave because for that derived average and RMS value like this. So, this is for that. So, like that, peak factor, it is another factor about alternating quantity. Peak factor is defined as the ratio of maximum value to the RMS value. Okay, it is the ratio of maximum value to the RMS value. So, I am writing like peak factor is equal to maximum value divided by RMS value. So, which I can substitute as maximum value, suppose IM divided by RMS value is 0.707 IM, which already we got. So, this gets cancelled and 1 point, so the value will be 1.414. You check with it, what is 1 by 0.707? It is 1.414. This is also for a sinusoidal wave. Okay, thank you. Up to this, we are concluding with the average and RMS value. In the next session, we will be dealing with the tutorials of average and RMS value. Thank you all.